Hello students, today we are going to talk about control strategies in AI. Okay, what is a control strategy? Control strategy or search strategy defines the rule or policy. Policy for what? Which decides the which node to expand next. There is a search tree. I told you in last videos, the search will convert it to the problem into a data structure or a search tree, which is called a frontier. Okay, now which branch to expand, which branch to explore is decided by this control strategy. Okay, that is control strategies dictate how search tree is actually explored. In any state, multiple actions are possible. One in any given state, there could be multiple actions that are possible at each node. A control strategy determines how the frontier or data structure is prioritized and how the node is explored. Unexplored nodes are explored using this control strategy. Okay, so there are two types of classification of control strategies. One is uninformed, another one is informed. Uninformed is blind search control strategy. Second is informed or heuristic. Okay, let's look at each of these strategy. Now, this control strategy, uninformed control strategy is it doesn't have any information about end goal to the, that is, if you are in a current goal, one state you are there, you don't know the end goal, where the end goal is. That is the key. That is how much distance is there from starting point to end point is not known in this uninformed or blind strategy, control strategy. Okay, it looks at state, action, results. Three things it looks at. One is state, current state. What is the action? The result. Examples of uninformed search are breadth first and depth first. Second is, I'll give a real time example. You will understand both this well. Please watch the full video. Second is informed or heuristic search control strategy. In this search strategy, it uses a heuristic function. It has additional domain knowledge where it estimates cost from start node to end node. Goal from starting point to end point, it notes the what the cost is. That is the key difference in informed control strategy. Two examples are there. One is greedy first and A star. We look at an example and you will clearly understand what both informed and uninformed are. Okay, let's get in. Real world engineering example. Packet routing in networks. What is a packet? The data, whatever we send across net using mobile or computer, it's converted to packets for routing it to in the network, internet. Okay. Now, consider a network router deciding to forward data packets across a set of grid of servers. Starting point is A, end is F. Okay. Now, A is the starting point. F is the goal. Okay. There are two paths are there. One is C, D, F. Second is B, E, F. Okay. Now, let's look at how in uninformed search works. Okay. Here, first is it's a blind search. It's a breadth first search is one of the uninformed search example. So what it does is it looks at starting point A, comes to B, E, F. There are three hops, 1, 2, 3. So A to B, E to E to F. Three steps are there. So what it does is it chooses this path. Again, the top also is three hops, C, D, F. But it doesn't choose that path, A to C path, because B is slightly before C in implementation queue. So it just looks at three steps. Top route is three steps, bottom route is three steps. So it takes the nearest one, which is A to B, B to E, E to F, which is the goal. It looks fine. Three steps only. Top route is three steps, bottom route is three steps. So there shouldn't be any problem. Looks practical and it looks like this shortest path. But the actual latency is actual time taken using this route is it didn't look at the cost of the path. That's where it's a difference. Here it is 3 plus 5 plus 2. What is that? A to B is 3 milliseconds. B to E is 5 milliseconds. E to F is 2 milliseconds. This is where is 3 plus 5 plus 2, which is 10 milliseconds. Okay. Now, this is the path cost that happens in BFS, which is 10 milliseconds. Now, let's look at informed search, where it's the same path is there. A starting point, B to E or E to F. The other side is A to C, C to D, D to F. Okay. So here what happens is A star, how it thinks is, how informed control, it uses a formula, heuristic formula. This is very important. Please remember this formula. F of n is equal to g of n plus h of n. When writing your answer, you should first, for heuristic functions, you should write this function and then show the working. Okay. Now, what it does is, A star is, it calculates the total cost from A point to F point in both the routes. ACDF route and ABEF route, both the cost it calculates. One is coming to 10, other one is coming to 5. So A star looks at the cost of it totally and it estimates the cost and then implements it. Now let's look at how this works. Here, diagram shows the uh, total cost is 5 milliseconds. Now, initial estimate what it has done is 5 milliseconds. Okay. Now, from A to C is 3. Okay. Then C to D is 1. Then D to F is 1. So, that is what is happening. Total expected cost 3 is used. That is when A to C happens, 3 is paid and 2 is estimated. That is H of n. 3 is G of n. Once it goes to C, 3 is over. It is that path cost is paid. That is G of n. 2 is the remaining path. That is H of n. When it goes to D, it is 4 is paid and 1 is estimated, which is H of n. Totally, the total cost is 3 plus 1 plus 1, which is 5 milliseconds. Okay. As it looks at the complete path cost, it is able to choose the best optimal path. That is the verdict. Optimal lowest latency is 5 milliseconds. A star strategy chooses such a path and moves in that direction. So this is what it is. Even though there are three hops B, E, F. Here also A to C, D, F. Both are three hops, but the cost for each is different. 3, 5, and 2. Here 3, 1, and 1. So it looks at the total cost and goes via the best possible route and the cheapest route. Hope you understood. If you have any doubts, please ask me. I'll try to explain. Also, subscribe to our channel. Thank you.